Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name is Ed Mann, and today we're joined by Jimmy Burrell. Hi, Jimmy.
Hello, Ed.
Hello, and Scott Wlaschin. How you doing, Scott?
Hi, I'm glad to be on the show.
Well, thank you so much for taking the time, both of you guys. I really appreciate it. We were just speaking off air, you know, at the time. Currently, for me and you, Scott, it's 3:00 on a Saturday afternoon. So I'm sure you could be doing something far more, fun than sitting on your computer talking to us. And also, Jimmy, at the beginning of the day, the last thing you want on a Saturday morning is doing this. But I really appreciate it, and I hope we can have some good time geeking out a little bit this morning and this afternoon. It's very strange time zones.
Oh, my pleasure.
Great.
The guy, just to point out, the guy who invented time zones is the Google Doodle today.
Is it really? I have to put that in the show notes. Man, time zones. So how are things going, Jimmy?
Oh, they're going quite well. Just learning more Fsharp and more functional paradigms and concepts. Lickety-split, as we say here.
Well, that's actually interesting you mentioned that, because that actually obviously is how we got Scott to come on the show. Really, is so through one of our podcasts we did last year. It was the falling into the pit of functional success. I tweeted it out there, and then Scott, you were kind enough to I think listen to it, or you at least kind of retweeted it and said but check this out. And then we started just having a little chat with you about maybe coming on, because we're really big fans. I mean, through the podcast we did then, talking about Fsharp for fun and profit, it's just the Bible. It really is.
Okay, well, thank you very much.
No, I really appreciate the work you do there. And so I thought, we'd devise like a little episode, maybe discussing like kind of functional programming, and then obviously dabbling into the Fsharp stuff. So kind of like I always like kind of started off with a guest is really kind of the root. How did you get into programming?
Well, that's a good question. I've been programming very long time, since the Earth's crust cooled, I like to say.
I do love some of your slides when you say, like, here's a picture of me on holiday. They are great little.
Yeah, that slide. That's for the people who haven't seen it. That's a slide with me and some dinosaurs. So yeah, I started off. Well, I tell you. So I actually I didn't have a computer science degree. I have a math degree, but and then I bummed around for a while. But then my dad had a K-Pro portable PC, or it was a CPM machine.
Yes.
This was back in the mid-'80s. That's how long ago this was.
Dark green.
Yes, it was a fantastic machine. It was one of those ones where it was a little metal box, and the keyboard kind of folded into the front of it, and it had a little CRT, yes, which is about 5 inches across. I mean, it was basically... And it was really heavy, that was the ultimate technology in those. The fact you had a portable computer.
A luggable
computer, yeah. Well, yeah. Anyway, so I started, and it had DBase 2 on it.
Oh, yes, and WordStar.
And WordStar, that's right. And I have to say, they were awesome programs. And DBase 2, the fact you could run a little database on this thing, and... it was actually super impressive, as long as you had to change the floppies every few minutes, but other than that, it worked great. So my dad, I ended up doing some programming. I got into it. I thought, this is the greatest thing ever, because this was sort of my first exposure to programming. And I just loved the thing that I loved then, and I still love now, is the thing that you can create something and you can kind of make it run, and it just kind of takes off. And it's a bit like, it was when I was a kid, I used to play with Legos. And, the idea, you take these little things and you turn, using your imagination and nothing else, you turn these blocks into a real amazing thing. And programming was how I felt when, that gave me exactly the same thrill. And I still get that same thrill today when I make something and it works. It's like being Frankenstein, So I got into DBase 2, and then I got a DOS machine that was pre-Windows. So I had a DOS machine, and I two things really changed my life then. First of all, I got a Turbo Pascal compiler for $99. And I have to say, Turbo Pascal was the most amazing program ever because first of all, it fit on one floppy disk. And these are the days when a C compiler, first of all, C compiler would cost you $500, maybe $1,000, some of them. Really expensive, and I couldn't afford it. And secondly, they would take up, you need to have massive, you need to have like a hard drive or something crazy on your computer. And the thing about Turbo Pascal was it was fantastically fast and it worked with floppies, and I think it's one of the best programs ever made, actually.
Absolutely.
And then later on, shortly after that, I got Smalltalk for DOS, which was incredible. And that, again, was very cheap. It was only $99. And that really blew my mind. So after I discovered Smalltalk, I was an object-oriented snob, actually, for a long time, because anyone who's programmed Smalltalk will realize that all other programming languages are basically useless, just compared to Smalltalk. And which is still true, by the way. I mean, because Smalltalk is more than a programming language; it's a whole environment. It's not really a language; it's an environment for creating programs. And it's hard to explain for someone who hasn't actually used it. It's really hard to explain why it's so cool. Mm-hmm. But it really it's because everything in it is an object. Everything in it is programmable. So it's not just a language. It's like its own little operating system, and so anything everything is an object, including the stack frame, including the compiler, including the all the windows and everything, and you have complete control of the entire system. And so that's really fantastic. You get this incredible sense of power, and it's incredibly beautiful language. It's very compact, and it's just what I like about it also is it's a very consistent language. There's only 2 or 3 things you can actually do. It's only got 3 keywords, and the only thing you can do is send a message to an object, and that's the entire programming language. And I have to say, I really am in all the languages I like this kind of having a single model of how the world works, rather than some languages like Perl, for example. You can do everything. It's a kitchen sink language. So I definitely prefer a language where, for example, I love Python for the same reason. It's like one way to do it,
Yeah.
So that's me. So then I got into doing Smalltalk. That's when Smalltalk was trendy, and you could actually get jobs doing Smalltalk. And so enterprise. In one of my slides, I make fun of enterprise OO versus Smalltalk. And the thing about when Java came out, and that was sort of the enterprise, and C++ as well. To my mind, they didn't really understand what object-oriented programming was, which was is a very, very dynamic, very fluid way of programming. And of course, enterprise programming is enterprise programming, no matter what language you're using. It felt like COBOL, basically. If you've been used to Smalltalk, Java is basically the OO version of COBOL. And so it's very heavy, everything's very clunky. And then, of course, the pattern book, when the Gang of Four book came out, that was very interesting. I mean, I have to point out that pretty much all the stuff in Agile development came from people who use Smalltalk. So
that is it's an interesting thing that does kind of, you do see the basis. It's like Kent Beck, loved Smalltalk and things like that. It kind of originates from that.
Yeah, Martin Fowler used Smalltalk, Kent Beck used Smalltalk. So when Kent Beck talked about test-driven development, that came from Smalltalk. When the Gang of Four, a lot of those patterns were Smalltalk patterns, and in the Gang of Four book, Smalltalk is one of the languages, and so it's very interesting that a lot of the Agile stuff is basically codifying Smalltalk patterns and practices and turning them into Java patterns and practices, and unfortunately, some of the stuff gets lost in translation, I think.
I bet.
And interesting then. So why is Smalltalk then? Why is it not as popular anymore? I mean, like, why do we not learn it? And because it seems like the people who loved it back then loved it and still have that passion for it, like you do.
Yes, one of the problems is it's a very. I wrote a blog post actually on this called "Introvert versus Extrovert Programming Languages," and some programming languages are very introvert. They kind of talking to themselves all the time. They really don't like dealing with the outside world. And some languages love to talk to the outside world. Some, like doing I/O is everything, is their whole reason for existence. And my feeling is that languages that like to talk to the outside world, extrovert languages, are popular because you actually get stuff done. You talk to the outside world. And Smalltalk is actually what I would call a solipsistic language. It's good at talking to the outside world, but it doesn't play well with other people. And so it's its own, because I say it's basically its own operating system. It's not just a programming language, and so it's fine. But it's in terms of working with the internet, this is because it came out pre-internet. When it comes to working with source control, working with third-party libraries, everything was just a little bit painful and a little bit of friction, and something it just wasn't natural to the flow of Smalltalk. Now, the Smalltalk people have actually solved all these problems, but it just doesn't quite fit. When you have to deal with the outside world in Smalltalk, it's always just a little bit, painful compared with languages which are really designed for that from the very beginning.
That's really interesting. And so obviously fast forward then ever so long and, functional programming. I'm just wondering, how did you actually get into functional programming then?
Well, I'm a bit of a language junkie, and so I've always liked learning new languages. So when I was learning Smalltalk, I was also learning Prolog, and I was playing with, Icon, and then Python, and then, so lots and lots of languages. And at that time, I'd heard about functional programming languages. At the time, the big one would be Miranda, which was sort of the predecessor to Haskell. But they were kind of big and slow, and I never really got into it. But then I think it was, for a long time, I was just doing enterprise stuff. I was doing a lot of C# programming and Python programming. I think around 2009, 2010, I was kind of getting bored of doing that. And I was like, okay, let's look around for another language to learn. And I thought, well, functional programming sounds cool. Let me look for a functional programming language. And then I realized that there was actually one built into Visual Studio, and that was Fsharp. And so I didn't even have to buy anything or install anything. I could just literally open a window and start typing. And so that's really why I got into Fsharp, just because it was the language that was right in front of me. It was already on my desktop,
That was my story with Fsharp as well.
Yeah, I was going to say, Jimmy, that sounds very much like your story.
It's nice to have it right. And I mean, unfortunately, it's actually not that way anymore. You actually have to install Fsharp. But at the time, it just came with Visual Studio. Actually, I think I did it before it was part of Visual. I did actually have to download it at the time when it was still a research project. But shortly after that, it was 2010. It became part of Visual Studio properly. So anyway, and then it's very hard. When you learn something, it's very hard to remember what it was like not knowing it. Mm-hmm. And I when I write my blog, I try very hard to think what it's like being an absolute beginner. And I remember when I was the first, probably almost a year that I was just struggling with Fsharp. And it's like, I don't understand, how can you even do anything if you can't have a loop, And if you can't assign, stuff, how can you do anything at all? I was thinking, these people are crazy, And so it does, I try and put myself in that mindset when I'm writing my blog post, because I think it's very easy to be snobby. Some functional programmers are quite snobby, and they say, well, it's obvious, it's just a catamorphism for this, and it's a user functor for this. It's like, I have no idea what you're talking about. And so, I think that's one of the issues with the acceptance of functional programming, is there's still quite a lot of kind of snobbery around it from certain quarters,
And so from there, because I mean, that's one thing actually from your blog that I really value, and I think it's probably one of the things I think it made it so inviting for me, was the fact that you don't come across as elitist, and you do understand these very mathematical concepts, but you're able to apply them and provide kind of like, here's actually how you would do something in it. And because I think as a programmer, yes, it's very nice knowing all these things, and I know you spoke about it on Functional Geekery, it's that kind of it's very nice knowing the mathematical stuff and knowing like kind of theoretical practice around it, but actually applying it and being like a humanistic programmer and someone who, actually, wants to build something, which, is where I come from. I love building things, from a young age. It was always, learning programming for me was like what you said at the beginning, where you're like Frankenstein, you're building something out of these small building blocks and you're able to get to somewhere and solve a problem. That's what really made me, really like your blog. Yeah,
that's exactly, well, that's why I try and do it. And I think, because the history of functional programming tends to have this mathematical background, people are trying to use mathematical approaches. And like I say, I definitely come from, I wouldn't say the hacker school, but the sort of self-taught, knock it out, build it, and have fun playing with things school. And that school is not really amenable to doing proofs and, all this kind of thing. So, I think, Fsharp is actually quite a nice language for that, because the community is not really, there are some mathematical sides of things, but it's not actually a powerful enough language to do some of the stuff that you can do in Haskell or other languages. So, and I guess that's what I mean by humanistic programmer. So let me just explain that. There's a couple of I think there's kind of two schools of programming. One is the mathematical side and the rigorous side. Like someone like Dijkstra is that it's about, if you can't prove what you're doing, you shouldn't be programming.
It's wrong, yeah.
It's wrong. And I have some sympathy with that, because a lot of computer programs are wrong, and I think any tools that can help us program better, because we are fallible. We're pretty, as humans, we're not very good at logic. Anything that help us program better, those are good things. But the other school is the Seymour Papert and the Alan Kay side of things. And this is the idea that it's about building stuff, and it's about having fun, and it's about changing the way you think. And it's about a tool for augmenting human abilities. Doug Engelbart is another person, or Ted Nelson. There's a whole school of people in that tradition, and I put myself in that tradition, which is it's how can we have fun? How can we use programming to change the world in a better place? And make the world a better place if we can. And it's about I guess it's putting people first.
That's it.
It's not programming for the sake of programming. It's programming for the sake of people. Programming as an end it's a people-oriented activity. It's not a mathematical-oriented activity. So that's the fundamental difference. And so yeah.
No, absolutely. And Jimmy, where would you put yourself then? What would you kind of, are you of the same ilk as us, or?
I was just thinking about that, and I absolutely did get into programming, much like you, Ed. I was fascinated at how you could build things. As Scott mentioned earlier, just take this box and these keys, and just by typing, you can almost build something out of nothing. And that really lit my fire, so to speak. And I absolutely recognize the truth of what Scott is saying. It is a people-oriented activity. And even though I tend to be more introverted and not apply programming in that manner as much as I should, I do recognize the truth of that. But I'm not the world's most social creature, despite popular beliefs.
I think the thing is like, I think that's very much a trait, isn't it, of our kind of profession and from where we've been, kind of the person. And I think, like designing things, I mean, it is one of those things where what's the point in something? Like, programs are there to solve a problem. And if the problem is just using like something else and not even an application, then that's the problem. So, that's the solution to use. It's kind of like the path to least resistance of whatever, you should use. And obviously at this time, functional programming is definitely kind of, it's more of the mainstream now, and it's really quite interesting. And on a other podcast, JavaScript Jabber podcast, actually, a person for Lee Byron from Facebook, he builds the immutable JS library, and he builds like the React stuff and everything like that. Works in their in-house team there, and he was kind of talking about like the two camps and kind of how functional programming came to being, because it's very interesting, kind of looking at the history and kind of like there's two forks in the road. There's fork in the road where it's split, where you've got kind of the part, you've got like the von Neumann architecture, and the Turing machines, and it's a very imperative programs, and you've got memory allocation and instruction by instruction. And then you've got the concept of like Alonzo Church's lambda calculus. And that's like mathematical, and then kind of at this time now, it seems to be diverging in. Scott, I'm just wondering, like, for you, like, this is a very hard question, but what is functional programming for you?
It's programming as if functions mattered.
That's
I love it.
I love it. That is a great answer.
Let me explain that. So, obviously, most languages have, most modern languages have functions or lambdas as something, as built into the language. I mean, Python has lambdas and Fsharp has lambdas and so on. Java has lambdas now. But it's programming as if functions are the main thing that you do. So if you want to do so, if you want to pass if you want to change the behavior of something, you pass in a function. If you want to build a system, you glue a bunch of functions together. If you want to extend the functionality of something, you extend you compose with another function. So it's just it's treating functions as the things that you do to make programs, which means that functional programming is a style of programming. It's not a purist. This is not a purist thing. I'm not, and purist in both senses of the words. Purist in the sense that it's, you can do functional programming in any language. You can do functional programming in any language that supports lambdas. I mean, C# and Java and Python. It helps if the language has tools to make it easy for you. If functions are carried by default, that makes life easier. If data is immutable by default, that makes things easier. So, some languages make functional programming easier than others. But I mean, there's no reason why you couldn't have functional COBOL, and no doubt we will see functional COBOL very shortly, given that we had object-oriented COBOL, and so. But some people define functional programming as in terms of pure functions using the mathematical definition, and I actually don't use that definition myself because that eliminates all programming languages other than Haskell and Idris, and
I started to say that was a Haskell programmer.
Exactly, and so I think it's a style of programming. It's not. To me, it's a style of programming. Now, when you start using that style of programming, having pure functions is very important because it makes composing functions very, much more sensible. And if you don't have pure functions, it makes it very hard to compose things. Functions that return unit, for example, that are all side effects are very hard to work with. And when you're composing functions from other functions, if they have side effects, it's hard to reason about them, and so on and so forth. But that is, to me, comes second from the concept that functions are the tool that you use to program with.
Fundamentally, like, why? I suppose it's interesting because it has, kind of, as say, these two, it's kind of diverged, and our languages that we use on a day-to-day basis, like the Javas and like the Pythons, they have these lambdas, and people, as you say, you can use functional concepts and functional ideas kind of in these imperative-minded languages. I'm just wondering, why are we caring so much now about these functional languages and really kind of investing a lot of time into them?
Well, that's a good question. I think it's because of it's to do with mutability and reasoning about the code. There are a lot of object-oriented patterns which are all about dependency management and about managing behavior. Dependency injection and the visitor pattern and the strategy pattern and the decorator pattern, and a lot of these things are really how to solve a certain kind of problem. And if you can bake the solution into the paradigm, these problems go away. So if you're just working with functions, if functions are all you have, then you do not have to worry about the single responsibility principle or the interface segregation principle. Yep. They just, every interface is becomes a one function, a one method interface. You don't have to define special interface objects up front because every function is an interface. You don't, composition over inheritance becomes trivial because you don't have inheritance, so you have to use composition. A lot of the things that we're striving for historically in object-oriented programming become very, very simple in functional programming. And I think so, ironically, I think that's why functional programming is becoming popular, because people are realizing that you switch to this paradigm and a lot of the problems that you have traditionally in object-oriented programming just go away. So I think that's why it's become popular. It's nothing to do with the mathematical side of things. It's just it's a pragmatic way of solving real-world problems. And I think that dependency management and separating. I mean, another good example is separating effects, managing effects. A lot of the stuff to do with dependency injection is trying to separate the I/O stuff from the rest of your code. And again, in functional programming, that's so much easier than it is in object-oriented programming. So
I was just going to add to that and say, from a historical perspective, also back when Alonzo Church and after that, even in the 60s and 70s, machines just simply weren't powerful enough to deliver the kind of functional language that we take for granted today. I guess maybe perhaps only in the mid to late 90s or somewhere around in there did machines really become powerful enough, I think, to give us the kind of compilers we take for granted today.
Yeah, I mean, although Lisp has been around, and I would call Lisp programming functional programming mostly. It's not pure, but you are programming with functions. And funny enough, Smalltalk is actually quite a functional programming language. In Smalltalk, you do a lot of stuff where you pass in lambdas to get stuff done, because like if you want to iterate over a collection, you actually pass in a lambda to a map function, because you're not supposed to know about the internals of the collection. And the lambda, it's not called a lambda in Smalltalk, it's called a block, but it's pretty much the same thing. So actually, funny enough, when I came to functional programming, and there were things like map and filter and collect and fold and all this stuff, they were already in Smalltalk, and so I had actually no problem with those. I was already familiar with that stuff.
That is cool, yeah. Because I remember I've heard like the collection pipelining and stuff in Smalltalk, and
Smalltalk kind of has the same pipelining thing.
That's cool.
That was a standard pattern in Smalltalk they call it the cascade pattern, where you just return something which gets piped, which is the input for the next thing.
So kind of like a composition of some regard, like kind of composing things together to build up.
Yeah, except the only difference with Smalltalk, you had to make an effort to do that. It was a pattern. It wasn't something that was inherent in the language. And in functional programming, you sort of get that for free, really. But it's definitely a nice. Smalltalk is it's hard to explain, but yeah, some of the patterns in Smalltalk are actually quite functional in a way. Yeah.
So you've got the functional programming, and then you've got the imperative programming. And you mentioned the object oriented that we use. I suppose we could probably say if you kind of take away Smalltalk and you look at like kind of the Javas and the kind of enterprise OO at this time, and it's interesting kind of like how you said that. Really, a lot of the problems that we've kind of solved in the OO world are simplified the solutions of them in the functional world. So would you say then that at this time it's maybe replacing kind of these object-oriented languages just with functional, or do you think there's a blend of both? Like there's pros to each kind of solution.
Yeah, sometimes object-oriented stuff. Sometimes you really need objects, and it's when that happens. It's really nice. Sometimes you need interfaces, especially for things like plugins or something. It's nice to have a language which supports both. I mean, that's one of the reasons I like Fsharp. It's a very pragmatic language. And so, the idea of having functional first, functions are the default way of doing things. And if that doesn't work, you can switch to objects with pretty easily without too much pain. And again, immutability by default, but if you need mutability, you can get it without too much pain. If you don't have any kind of immutability, and if you don't have any kind of object-oriented stuff, in a pure functional language, you have to then jump through hoops to get that, and which is what Haskell you have to do in Haskell, and you could defend that by saying, the jumping through hoops shows that you're not doing it. It shows that it's a sort of an anti-pattern, and so it's deliberately hard because you don't want to do it very often. But I don't know. I'm pragmatic, so sometimes I like to take the easy way out and just define an interface or something, and just I'm not. I guess I'm not a purist in terms of. I don't think. It just comes from the thinking of programming as a people-oriented activity rather than a mathematical-oriented. I don't really care how you do it. I'm not one of these people who really cares how you program and is very dictatorial about it. As long as you solve the problem.
That is exactly it. It's not a science. It's not a mathematical kind of thing. It is, as you say, a humanistic, a people person thing, and it's solving problems for people. And it just so happens that the way you're solving them is through building a program.
Yeah, and also the other thing is almost all problems are not technical problems. Almost all problems are people problems. And it's all about understanding the requirements. It's all about, delivering something that people want. I very much doubt. I mean, if you look at if functional programming is so great, or every time there's a new trendy programming language, I always say, if you look at the businesses which are successful at solving problems, they use all sorts of programming languages. I mean, Facebook uses PHP, for God's sake, and they're very successful. So it's not, you can't say that if that PHP people are going to fail and Haskell people are going to succeed, because the evidence is exactly the opposite. So I mean the irony is, of course, that Facebook is now hiring Haskell people to kind of fix up some of the problems with PHP, but getting stuff done. I mean, that's after they've already got stuff. They're using that to. So I mean, it's just interesting to see. To me, it's about getting stuff done, and to me, a type-safe, relatively pure functional programming language helps me get stuff done better. I mean, I find using PHP quite painful, and I find using Fsharp easier. So, from my point of view, that's why I like to use a programming language. But in terms of actually solving a business problem, I don't care. It's solving the problem is the important thing.
I've either heard you say. Make that remark before about most problems being a people problem, or I've read it on your blog. I'm not sure or on your website. I can't remember which, but I strongly agree with that. And I think partially it's my history or the quantity of time that I've solved problems with computer programming languages. You come to realize that over time. But I heard you make a comment there that I'd really like to ask a question about, and that is the types. I've found that, for me, programming in Fsharp is one of the best typed languages I've ever used. And I wonder if you could contrast a typed language like Fsharp, or just Fsharp, I suppose, with the kind of types we used to have in languages like Turbo Pascal back in the day.
Yes, well, I think there's a difference between, to me, this is the difference between a type versus a data structure. So in Turbo Pascal or in C++, in C++ or C# even, you're normally creating data structures to store data, and you have to give them a name, and so they are sort of types, but that's really what they're for. I think in functional programming, because everything is inputs and outputs, and because of the kind of mathematical background, you tend to think of types as the valid input for a function. So, and the valid output for a function. So, I mean, a good example is if I'm trying to validate an email, the input is some sort of string, but the output is not a string. The output is an element of the set of all valid email addresses. And so I want to represent that as a type. So I give that thing a name. The set of all valid email addresses I will call email, email address. I'll give that a type name. And then another program which wants to send an email, I can say, well, the input for that program should be a valid email address. And rather than saying, well, this is a string that just happens to be a valid email address, I can represent that as, I can say, well, it has to be in the set of all valid email addresses. And that's the same type that was the output of the validation step. And so you're using types to define the valid inputs and outputs for each step in your program. And to me, it's quite nice, because you sort of do that implicitly anyway. Just the fact you can give these things labels makes the domain much more explicit, and it makes your code much easier to understand.
Would you say this is somehow related to a phrase that you hear in the functional world a lot, or rather in typed languages a lot, I guess, a type system that helps as opposed to one that gets in the way?
Yeah, exactly. Yes, because I mean, if most people think of a type system, especially in C# or Java, as something that it's annoying. And it's like I have to, especially one of the reasons is you have to explicitly put all the types, in the parameters. Every single parameter has to have an explicit type, and the return value has to have an explicit type. And when you have local variables, you have to give them an explicit type. And, you just, after a while, you get fed up of doing that. And it's one of the reasons why people like dynamic language. It's one of the reasons why Python is such a nice language, is because you can just start coding and you don't have to worry about all this stuff. And the nice thing about Fsharp is, well, first of all, you don't have to declare the types most of the time. You get the type inference, so it looks like Python. But yeah, the using types as the API is just a nice way of doing it. Yeah.
No, that's incredibly interesting, actually, and it's really interesting because in one of your talks, actually it's the DDD one, where you discuss kind of like how to use a good type system to actually define your domain. I thought that was a really great talk, and actually in another one, the functional design patterns one, you actually talk about, say, one of the core principles of functional programming for you is that types are not classes.
Yes.
Would you mind kind of elaborating on that and what you mean? What is a type then in a functional paradigm, as opposed to what we kind of observe it as in the object-oriented type?
Yeah, so again, a type is just a set. It's just a name given to a set of values. So the set of all valid emails, the set of all valid customer IDs. Obviously, by the way, I just want to say I'm oversimplifying. In the academic world, there's big debate about what is a type, and there's lots of discussion. Thomas Petracek has a good discussion of that on one of his papers. But from my point of view, a type is just a simple set of values, which is, again, it's dumb. Well, first of all, in object-oriented world, a class is meant to be a self-contained thing, and you're not even supposed to know what the data structure is in a class. In a true object, the closest model for true object-oriented programming is the actor model, where you send something a message. You wanted to do something, you send it a message, and it does it, and then it sends you back the result. That is, to me, the true model of object-oriented programming. And in Smalltalk, that's exactly how it works. You send things messages. And so the whole point of object-oriented is all about the behavior. You're not even supposed to know anything about data. Data's not even supposed to exist. It's all about the behavior. So when I have a collection or something, I don't care how it's implemented. It just has certain behavior which I care about, and I send it messages and ask it to do something. It's very anthropomorphic, And in functional programming, a type is all about the data. There's no behavior anywhere. So in the types are very dumb. It's just a set of literally a set of data, and that's all it is. And that's a big paradigm shift when you're coming from OO. When you spend a lot of time trying to encapsulate things and working out the behavior. And in functional programming, you have this data and the behavior or the functions are completely separate. And the data, it tends to be exposed, which is very scary if you're coming from an OO world, because you're taught not to expose your data structures. But I think one of the insights I had is that because the data is dumb, you can compose the types just like you can compose functions. So you can glue two types together to make a bigger type. And that's not really possible in OO, because you can't really glue two classes together to make a bigger class. You have to write a lot of intermediate code. But in functional programming, you literally can just use a tuple. You can glue them together sideways, or you can glue them together vertically, which is like union types. And that composition of types relies on the fact that types are dumb and they have no behavior. And so it sounds like, it's I guess that's the difference also between functional model of types versus the model that you'd have in C or C++ or Pascal of data structures, because you tend not to compose data structures in the same way. You actually have to, it's not quite as easy to do the same thing. So I think the model of composition everywhere is definitely the kind of functional worldview.
And one thing actually, so with like the kind of another thing from that talk is really interesting is the kind of the differentiation between like input and output, which is what a function does in a functional language, as opposed to the response, that you get in like the OO world. I'm just wondering what are the differences then between the two?
Yeah, I mean, it looks like it should be the same thing, but I think again it's a mental shift. So like I say, in the OO world, I think of actors. And you send a message, and it's a request to the actor of the object, and they deal with it, and they send you a response back. And it's just, I guess, the request-response model means that if you go to like the distributed actor model, you might not get a response. And so the idea is once you've sent a message, it's really fire and forget. But the input-output model is. It's very clear that if you have an input and an output, you can then glue the output of one thing can connect the output of one thing to the input of the other thing. That's why I like that railway track metaphor that I use all the time.
It's such a great metaphor. I really do like that.
Yeah, because that's exactly, I mean, it makes it really obvious that...
It's like a Hornby track that you're just building together. That's it. Yeah. Absolutely.
Yeah, I mean, and to me, if you have that metaphor, makes it really obvious that that's how you make things. You glue track together and you get a bigger piece of track. And so the object model, you can't, even though I say it's the request response in theory should be the same, but in practice, it doesn't work that way. You have to if you want to glue two objects together, you have to then create a new object and then put both of them inside, and then you have to wrap all the methods. So think something like the law of Demeter, where you're not supposed to access the internals or something. You're not meant to dot into things too much. So if you want to compose two objects, you have to write a third object, and then for every single method on one of the inner objects, you have to basically write the same object on the same method on the outer object. And that's very painful, and I'm sure we've all done that, and that's kind of an anti-pattern.
It's an explosion of methods.
Yeah,
absolutely.
And it's an anti-pattern. You're doing it just so that you can pass through data to one of the inner objects, and when you're doing that, it's like that feels nasty, and it feels like there's you shouldn't be doing that, and you shouldn't be doing that. And it tells you that there's a problem with your paradigm if you have to write a lot of boilerplate code to do something which really should be straightforward.
I think that's one thing with these functional languages that really, you can you see the meat of the actual problem more often, as opposed to, and again, this could be the enterprise OO world where you do see a lot of boilerplate that has to be created every time. Yeah,
and then you have things like dependency injection. In the OO world, you have dependency injection, then you have a debate about how you should do dependency injection. Should it be through constructors or through properties? And then you have dependency injection frameworks, inversion of control, IOC containers, and you have all this stuff to solve one problem, which is how do I pass something into another object. Now, in the functional worlds, you don't have that. The whole problem just goes away.
You're just passing functions.
You just pass in functions, exactly, and it's not anything.
Functions are values. It's just great.
Exactly, and it's nothing special. You don't have to come up with a whole new pattern. It's just, the language supports it out of the box. So I guess that's an example of why I think functional programming is nice, because you kind of get this stuff for free. Now, there's always a downside, and especially in a tight functional language, it's quite easy to be snobby and say, this is so much superior. But, the functional programmers also do jump through hoops to do something that's trivial in a object-oriented language. So I'm not going to be too smug about that. But for a lot of things, I still think the functional model is better by default. As a starting point, it's a great starting point. Yeah.
And another thing, actually, in the same presentation that you give is the idea of like totality in functions, and that it blew my mind. It was aha moment with a lot of things, and it's how, again, it's one of these things where we've kind of, I wouldn't say solved it in the wrong way, in like say in these enterprise OO and kind of how we do it with throwing exceptions and stuff. But so what actually does then? What do you mean by function totality?
Just that every input has an output. So a function that says it can handle an input but doesn't, throws an exception or just crashes, is very hard to work with. And so in that talk, I gave the example of dividing by zero, a function that accepts a zero as input, and then if you give it a zero as input, it just crashes. And to me, that's a bad function. It makes it very hard. If some inputs just crash, that's a bad design.
You can't reason about it, can you? Really?
Yeah. It's just annoying. And so, and this is where the types come in. So you can just say, I define a type called non-zero integer, and that is the input for this function. And if you give me one of those things, I guarantee I'll never crash. Or in that example, you can also extend the output. So rather than saying, I'll always give you an integer back, you can say, well, I'll sometimes give you an integer back, but if you give me a zero, I'll give you nothing back. But in either case, your function doesn't crash.
That's it. You're constraining it in such a way that allows you to always reason about it correctly.
And not only that, but it's self-documenting. If I have a function that says it takes a non-zero integer as input, it's very clear that what this function is needing, or if this function sometimes returns something and sometimes doesn't because it uses the option type, again, that's very clear that you'll have to handle the case when it doesn't work. But it's not going to crash the program. It's going to make it very explicit that you have to handle the case where it couldn't do something. And so that way, total functions, not only are they nice because your program doesn't crash, but they act as they forces you to make the functions more self-documenting. I mean, there's a lot of object-oriented, in classic C# and Java, you have these functions, and it's like they could throw any of 10 different exceptions, and you've no idea, really, without reading the documentation, what's going to happen. Now, it's true that some exceptions, out-of-memory exceptions and stuff, you can't handle
they're
those.
Exceptional.
Yeah,
they are exceptional.
Yeah, I mean, in that case, your program should just crash. There's no point trying to handle that. But, a divide by zero error shouldn't crash your program.
And you should be handling that with the domain
Exactly.
that you're within.
Exactly. It should be explicitly documented that this is the valid input and this is the valid output. And again, this is the way of thinking. When you start thinking of inputs and outputs and you go through that paradigm shift of thinking of functions that way, you start seeing all this stuff, like the whole thing of totality. It's something which is kind of obvious when you have functions, and it's not at all obvious when you have objects, because it's not it's not obvious that it's a problem with objects. Now, I just want to point out in Smalltalk it's not a problem either, because in Smalltalk it's only a problem in typed object-oriented languages. In Smalltalk you would return nil or something. You don't throw exceptions in Smalltalk either, but that's because it's untyped. It's a dynamic language, so you can return any type of object. And so in that case, you just return a different kind of object, and that's not a problem because there's no types. So it's these hybrid languages like C# and Java where you have to return. The type system says that you're returning an integer or a string or whatever, but it's actually lying. And to me, that's the worst of both worlds. If you have a pure dynamic language like Smalltalk or Python, or Ruby, it's not a problem. If you have a strict functional programming language like Haskell or Fsharp, it's not a problem. Funny enough, it's the typed object-oriented languages where I think you have the most issues. They're basically lying about, and so you have to invent exceptions, and then exceptions, of course, are just a terrible thing.
So that's what I was going to ask, like your opinion on exceptions, and how kind of, so taking the concepts that you have from the functional world now, and if you do have to go back to the C# and those kind of, and even Javas maybe, like how has you found that like your programming style has changed?
Yeah, it's definitely changed when I write C#. I tend to, for starters, I make everything immutable by default now. I use lambdas everywhere. And if I want to, so for example, if I'm doing the strategy pattern in C#, I would probably just pass in a lambda. I wouldn't bother to define an interface and then pass in an instance of that interface, So that kind of thing. And I tend to worry about what the output of something is. In object-oriented program, you tend to worry about what the input is, but the output normally just mutates. You don't normally have an output. You tend to just mutate the object.
That's it. You get void, and then it's just like
you have a lot of void methods, and I try and avoid void methods now. So that's something. And I have even used. I mean, I do even use things like option, and I use the result type, the success or failure type, and I use the option type, and even in C# I try and do that now. It depends on the team that you're working with, how sophisticated. There are some people who do some really serious functional programming in C# where they're using monads and everything in C#, and you have to have a team who already understands functional programming before I would do that. I would always care about making sure the code is maintainable by other people.
Again, that's the humanistic side, isn't it? And kind of being pragmatic and actually caring about, again, it's designed by humans for humans.
Yeah. It's, you have to, it's all about designing something that works. There's nothing more annoying than someone who comes onto your team and rewrites all your code to make it perfect.
Yes.
It's like, I mean, I've probably been, when I was younger, I plead guilty to that myself. And I think that's so.
You just get a pull request with just all these changes, and it's just like, lovely.
Yeah. I'd rather just I'd rather write when I was younger. I tried to be clever, and I was trying to be using the cool technology and the cool, And if something new came along, if you just read an article by something, it's like, oh yeah, let me change all my code to use.
That's it. Let me do that now. And you want to be look at me.
Yeah, exactly. And so now I try and write my code to be as straightforward and as dumb as possible. And I basically try and avoid tricks, and I'm actually very anti trendy stuff. So I basically don't use any library which hasn't been around for a couple of years, So if I was a JavaScript program, I'd be pulling my hair out. I couldn't survive. So. Oh
man, the churn rate is
exactly.
Just ridiculous,
I couldn't do that, and again, because it's about solving problems. So I have no problem using a library, which is 5 years old. If it's around, if it's working, great. So yeah, it's not about being clever. It's about getting the job done and trying to make it obvious for somebody else who comes along. So even in my Fsharp code, I try and make it as obvious as possible. I avoid clever tricks if I can. Because first of all, I'm not as clever as some other people. I mean, there's some amazing stuff that people have done by people who are much cleverer than me. And I'm, in awe of some of that stuff. But I personally try and just stay away from clever stuff.
Well, I think that's a great way to be. I really do. And actually, so it's following on, I know you've mentioned actually kind of composition. And that's one of the key things as well with functional programming and building up and composing functions together and putting, different bits of railway track together to make new, encapsulating them. And actually one thing that I really thought was great. And again, it was this aha moment of building applications and like people thinking, well, yeah, it's fine. Can you use functional programming languages for this? Can I build, the simple web application that I would actually have? And if you decompose it, you've got your low level operations, like your string to upper and all this type of stuff. Then you compose them to be services and you compose them to be use cases. And eventually you compose them to be web applications. And I'll just say that really to me was a great kind of reasoning about it.
Yeah, I think it's I guess it's the nice thing of using the same pattern everywhere or the same approach everywhere. It's nice to me if you don't have to kind of switch to use different styles of programming depending on the size of the program. And so to me that makes sense that once you have that way of doing stuff, you can use it at a very high level, you can use it at a low level, and it's the same approach.
No, it's absolutely great. And one thing you do say is that encapsulation is fractal.
Yeah.
Would you mind kind of mentioning what you mean by that?
Yeah, well, first of all, fractal has a specific mathematical meaning. So in fact, it's not really fractal.
To be fair, you do always disclaim with that. You do say that every time.
That's because I have a mathematical. It's like my mathematical friends will beat me up if I say. It's like people using exponential or something in the wrong way. It's just something that annoys people. But in a sense of self-similar, that using the same. One thing about fractals is that the scale, things look the same at different scales. So, I mean, that's one of sort of the definition of it being fractal, is that you look at a piece of coastline and you can't tell whether the coastline is, 50 miles along or it's like 10 feet, because it's just a ziggy-zaggy in both cases. So the functional programming is the same thing. It's you're gluing functions together, and whether you're gluing functions down at the micro scale or whether you're gluing functions together at a macro scale, at an application level, you're using the same techniques in both cases. You don't have to use different techniques. So that's all I meant. It's just me trying to use a clever buzzword to make people.
Well, no, it makes complete. I mean, it really does make sense. You know what you're saying. The macro micro level is exactly the same. And it simplifies kind of our thinking about how building applications, from the small to the big, you're using the same reasoning. Yeah.
And I like models where there's a consistent approach. Functional programming has that. Now, funnily enough, proper object-oriented programming, by which I mean Smalltalk, has the same approach, because everything, even integers, are objects. So you don't have this distinction between value types, reference types, and value types, and primitive types versus classes, and so on. They're all the same thing in Smalltalk, and so that's one of the nice things about Smalltalk. Now, in C# and Java, they make a distinction between integers and objects, and again, so you have to be aware of that distinction, and you lose some of the purity of the design.
Yeah. It's interesting. Why is that? Do you think it was just because of the transition to get people to use OO languages? It would be too much, or is it an optimization issue? Because I know, like Scala, they have they do. I suppose in Java as well, you do have the integer class and stuff, and it can be auto box and unbox and stuff, but still maintaining those primitives as a distinct thing compared to being like an object.
Yeah, some of it's performance. I mean, it is true that having value types really helps with performance. So, stack-based types as opposed to types just put on the heap, values that are put on the heap. That's really nice. So, yeah, in a language which doesn't do that, then you do have performance overhead. I guess that's the kind of thing about being pragmatic versus being pure. I think I'm not a Ruby expert, but I'm pretty sure that Ruby treats integers as objects.
Yeah, that's another language that does like a nice thing like that, where everything's an object.
And even something like Objective-C. So Objective-C was trying to port Smalltalk concepts to C, and in my mind, they did a pretty good job. It's a kind of bit weird, but if you understand Smalltalk, a lot of the stuff in Objective-C makes a lot of sense. If you don't understand Smalltalk, a lot of it just seems downright weird. But I think it's just it doesn't. You can do it. It's just it was a decision I think they made to make life easier for themselves. And also you don't really have the whole meta programming stuff in Smalltalk. Everything is an object, including the classes. So you can ask an object what its class is, and then you can ask the class what its class is, and you can ask the class what its class is. Everything is an object.
There's no language construct that is just that. Yeah,
you don't have a special kind of reflection libraries like you do in C# and Java. It's just everything is the same. So in the kind of statically typed object-oriented language, you have to understand that there's different layers. You're not using the same paradigm. If you're doing reflection, that's very different from doing regular programming, and primitives are different from objects, and so on. So you have to understand all that stuff, which you could argue gets in the way. I mean, someone like Alan Kay would say this is just getting in the way of understanding how programming works. And the pure, you'd say that the argument that Alan Kay would say is just focus on the human side of things, and the machine will eventually catch up. The CPUs will eventually get fast enough that you don't have to worry about it, which is pretty true. Of course, programmers always find a way to make the CPUs slow, no matter how fast they are. That's our fault. That's not the. I mean, that's not the language's fault. Smalltalk is super fast on a modern computer. There's no problem there. It's designing the systems, writing all this code that makes things slow.
Zooming out really, this is what we're talking about: architectural patterns in the macro. Going back to the fractal. But are there, Scott, in your experience, are there any program architectural patterns that are more or less suited to functional programming languages?
Yes, I would say that microservices and using queues. I mean, one of the problems that you have with using functions as the building block is you do hit a barrier. At some point, your function reaches a certain size, and you have to have some input and output for that function. And functions need to communicate with other functions to get, in a big application to get stuff done. And to me, using queues is a perfect way of doing that. This function does something; it has some sort of output. Some other function is going to process that output, but I want to decouple these functions. I don't care. I don't really want the first function to know about the second function. So the first function is just going to take the output and stick it on a queue, and the second function is going to take its input from some queue and process it and stick it on some. Its output is going to go on some other queue, and that's going to be the input for a third function, and so on. To me, that's a very natural model for very large scale functional programming. And of course, that is very much what stream processing is like, and what microservices is like, and so on and so forth. So a lot of the trendy stuff in current architectures, again, I think that's suited quite well for functional programming, because I think functions, when they get too big, if they have too many dependencies, and they just become, just like anything, it becomes unmanageable. And that's one of the nice things about this, is again where the language helps you, because in a particular function, you have to pass in every single dependency for that function, because there's no global. You don't have to, but that's the idea. It makes it, the ideal is to do that, and it's kind of easy in functional programming. But if you start having 10 dependencies, 20 dependencies, 50 dependencies, it gets really hard. It just becomes harder and harder and harder to work with. And so at some point there's a natural size to a function which it just becomes unmanageable to have that many dependencies. Mm-hmm. And at that point, your function is probably big enough. Your function at that point is probably trying to do too many things. And this is where you get the kind of single responsibility principle falling out naturally. When you have too many dependencies and you're passing, and then your function's probably doing too many things. And rather than having to have a pattern that says, okay, don't do that, you naturally don't do it because it's so painful. And so you naturally sort of have an upper bound on the size of a function, and that means now you need to focus on how do the functions communicate with other functions. And that's, like I say, naturally either using queues or, event store, or I don't know. But, all the kind of trendy patterns, log-based things like Kafka or something, all the trendy patterns just fall naturally out of dealing with doing functions at large scales. Yeah.
So it sounds like the internet is a good problem domain for functional programming.
The internet is quite a big. Yeah, I mean, the internet is an interesting. Architecturally, the internet's a very interesting system. And I mean, the internet is basically the actor model writ large. At some point, when you start having functions and queues, then you're kind of leaning back towards the actor model. I guess the difference is that with pure functions, the actors are pure actors and they have no internal state. And again, that's one of the desirable things to have in actors, is to have stateless actors, because they're scalable, and scalable is the buzzword, But it also makes things easy to reason about. So yeah, stateless actors are basically like functions with queues. So they start blurring into each other. A lot of the things. Again, there's no answer. There's no perfect architecture, but that's how I would do it if I had a very big system and I needed to have functions that communicate with each other.
Actually, another interesting thing that you, again, in that talk, and this talk, I've listened to a couple of the ones you did, because you have a couple recordings of them, and they're slightly different, and like one was a little longer, and it was really interesting to go through them all.
And by the way, I should point out that I don't claim to be an expert in any of this stuff. I do this. I like to help other people learn, and I learn by doing that. I learn myself. So anyone listening to my talks shouldn't say this is the only true. I'm not trying to say this is the one true way of doing things. This is just my opinion, and it's sort of what I've learned from my own way of thinking about things. So, But
I think that's the great thing about it, is you're coming from a mindset of, teaching and not trying to be, elitist and stuff, and understanding, that, to be in the mindset. I think that's where the blog, came in, where you were learning when you were doing the blog. So that, the reasoning and the understanding comes from a place of someone who's trying to learn, as opposed to someone who's mastered it already and is trying to say, well, don't you already get this? Like, I know this, it makes sense. And, being able to unlock it in certain ways as being that. I think there's the value in being kind of always being the learner and always being kind of the novice.
Yeah, I think definitely. Certainly, I I feel like I'm always learning, but yeah, I definitely try and approach things from that way. And people who know more than me, if people who are kind of saying, it's a different style of learning. And I think, just to go back to the mathematical thing, I think that's also a subtle difference between the math, the way that math is taught. Versus other subjects are taught in a typical, like in a university math course, they give you a theorem. Here's this theorem. Let's prove it. And you spend a lot of time, and you don't even know why this thing is useful. And part of the theory is that we shouldn't even care, because it's a very beautiful theorem. And then, but if it is useful, that normally comes later on. After you've done it, then you realize. Then they say, okay, well, here's all the ways you can actually use this thing in practice. But it's the model for mathematical teaching is to give you the answer and then give you the reasons for the thing afterwards. And to me, that's fine in an academic setting, but in people who are teaching themselves anything, I think it's really important to have the motivation and to have lots and lots of examples. And so I always try and say, well, here's an example of something. How would you solve this? Oh, here's another kind of problem. How would you solve this? Oh, well, there's something in common with these solutions, and now we're going to give it the name. We're going to say, okay, this is what a monad is, or something, rather than saying, here's the definition of a monad, then why is it useful? And that's why people get so freaked out by all this jargon, because you're giving people all this jargon rather than saying, here's a particular practical problem and here's a particular practical solution. And to be honest, you don't even need to know the names of the things. If you've got a solution to something, fine. You don't need to know anything more than that, really. If you want to learn more than that, that's fine. But from a solution point of view, if you've got a solution to a problem, the fact that you call it a certain name and it falls into a certain pattern, that's actually irrelevant initially. It's only when you get more experience that you might start seeing patterns across multiple solutions. But initially, why should you even care?
As a newcomer to Fsharp, I can identify with that by going through your railway-oriented programming material on your website. I learned about monads, and I did not even know I was learning about monads.
Yes, exactly. And it's like, well, I don't see monads is this kind of horrible buzzword that really interferes with learning, I think, because you don't need. Technically, they're not monads; they're an instance of a monad, and you don't even need to know that to solve that particular problem of error handling. That, those are the tools you can do with error handling. And if you've got another problem like working with async, then there's a tool for that. And if you're working with lists or something, there's a tool for that. The fact that they have something in common is actually really not relevant when you're first starting out. And that's, I guess, one of my concerns about Haskell is you have to learn about monads before you even get to Hello World. Like in the Haskell books, Hello World is normally like in the 7th chapter. So you have to learn. So you have to learn about monads before you can even print "Hello World" to the console.
Yeah.
And I mean, I understand why they do that, but to me, that's a bit much. That's why people find Haskell so scary, I think, because you just want to start getting stuff done, and all this other stuff. I think the patterns come afterwards, after you've got a lot of experience with different solutions. When you see some commonality between the solutions, then you can give it a name. But giving it the name first, expecting people to memorize the monad laws, and then trying to figure out why this is useful, I think this is totally the wrong approach to learning functional programming.
Kind of tough for sure.
Yeah.
I have found your website to be very helpful, and I would just like to say thank you very much for all that material. It's obviously a labor of love, because, boy, you have quite a volume of content. I'm still working through it, in fact.
Yeah, I have a lot. I don't know. I guess it's because I'm very long-winded when I write my each of my posts. It's like I just need to say this. Oh, and I also, just in case someone has this question, I should probably just answer this question. And they end up being super, super long. And I guess that's okay because people seem to find it useful. But yeah, again, every time I try and learn something, I try and make it into a blog post. So I haven't posted very much last year, but I'm going to try and post a lot more this year. But it's just kind of a labor. I really enjoy it. I mean, it's satisfying to me when people say nice things about the blog. That's kind of nice,
Absolutely.
And with actually the railway-orientated programming kind of concept, I'm just wondering, would you mind explaining what that actually is then? And also, how did you come up with the railway analogy?
Yeah, okay, so I've been using the railway and the functions as railways with the inputs and outputs. And because that's I don't think I'm the first person to do that. And then I was teaching myself the error handling, and there was I had to read a lot of Haskell blogs, and I was like, I don't understand. They're talking about either monads, and it's like, what? And so I was thinking, well, the fundamental problem is you have, inputs and outputs, and you have two outputs rather than one output.
Got a set of points.
Yeah, and so it's like, well, okay, if I was using the railway analogy, that would be like, some points or switches in American, and the problem then becomes how do you glue those together? And to me, then it made a lot more sense to me. I thought, well, this is quite a nice way. It helped me understand it, and I thought, well, maybe I'll explain it to other people this way. And when I first posted that, I thought it was actually a really terrible post. I thought I was kind of embarrassed by it. I thought, this is really, are people going to hate me for posting this? If you look at my original tweet where I did that, it came across as like, I think this is a really bad analogy, but hopefully it'll be useful to somebody. And it turned out to be my most popular post, so that was interesting. And it really turned out that a lot of people seem to like that analogy, which goes to show that metaphors are important. The whole railway-oriented thing. People have, some of the functional people have, the serious functional people have been very critical of me for dumbing down monads and saying you're using these metaphors and you're really hiding what's really going on. And in my post, I actually do address that, and it's like, I don't think so, because I'm not, I'm trying to get the concepts across. Once you get the concepts across, then you can go back and look at monads, and the monads make more sense then. But I think getting the concepts across is much more important, and if you can use an analogy to help that, then I'm in favor of that, totally.
So actually, what has the reception been from your mathematical friends and the stuff? You say that, do they find, say, these analogies and these kind of metaphors a little bit kind of wrong, or are they happy that you're bringing more people into the world of kind of understanding these things?
Well, it depends on it's what's interesting is the real mathematical people have no problem with metaphors and analogies because they use them all the time. And this is actually, I think there's a little bit of math envy in the functional programming world. Because it's like we want to be more mathematical. But like in my experience, mathematicians have no problems with using visualizations and analogies and stuff because they think that way. It's if you're coming from the serious mathematical side of programming, some people think that you should really just the Dijkstra model is like, don't try and cover it up, just, tell the truth. But like I say, I think that's the truth. Things like using monads, that's a very Haskell-oriented way of thinking about it. You can use these same concepts in C# or Python or JavaScript, and that you're not really using monads. I think that's you're imposing mathematical terminology. So my pure math friends, would be very skeptical, because a lot of the stuff, programming isn't maths. I guess that's another division. I don't think programming is mathematical. And there's so many, a mathematician would laugh their head off at some of the things that programmers say, because, like, for example, well, I mean, I'll give you a good example. Let's say that in math, you can just say a triangle, has 3 points, which are not in a line, right? That would be a sort of a definition of a triangle. That's a definition of a triangle, right? In a mathematical, that's it. You don't have to prove that a triangle has 3 points. Now, in programming, if I define an interface, an I triangle interface, I might have to have some unit tests to prove that the triangle only has 3 sides, and the only 3 points, and the points aren't in a row, and the points aren't, I have to write all these tests, and it's like, you don't have to do that in maths, because it's you don't test that a triangle has, that's by definition. So the very fact that you have to test something makes it automatically to me, that's the difference between programming and maths. You don't have to prove anything. Even in a language, a serious proof type language like Agda or Coq or something, you still don't prove. In mathematics, you don't prove that a triangle has 3 points. That's not something you have to prove. It just comes out by definition. So, for example, in the example in monads, in mathematics, the monad laws are not monad laws. They are by definition what a monad is. You don't have to prove that a monad supports these things. That's if it doesn't support the thing, it's not a monad. But in functional programming, you might have to, in a programming language, you might have something called a monad that's not actually a monad until you prove that it supports the monad laws. So to me, that's really, actually, from a mathematical point of view, that's actually making things more confusing. Don't call something a monad if it isn't a monad, So, like in Haskell, you have a monad type class, and then just because it's a monad type class doesn't mean it satisfies the monad laws, and they're impure. Even in Haskell, you can throw exceptions, and so there's just a whole, I guess I'm leery about trying to impose mathematical concepts on programming. I really don't think it's that helpful, because it's not really proper mathematics. Proper mathematics is coming from somewhere completely different from programming.
Really interesting. And Scott, thank you so much for taking the time to come on the show. It's been so interesting. And Jimmy, have you got any other questions?
No, I think not. We've probably detained Mr. Wlaschin.
I was thinking we've racked up at least an hour and a half with you. Again, really appreciate it.
That's all right. It's fun.
Brilliant. And I mean, we've got, obviously, there was a couple of bits we weren't able to touch on there, but it'd be great maybe to get you on the show again sometime. We could geek out again a bit.
Sure, I'd be happy to.
Awesome. All right then, audience. Well, it's been another great episode, really interesting, and we'll speak to you again next week. Goodbye.
Bye.
Bye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.